Look at the fractal tree pattern that I have on my screen. Do you realize that now for every branch that goes out, not two, but in fact, there are three branches going out further. So notice here, I have, one branch coming out, three branches get out of this. From each of these, another three branches get out. And hence, the pattern looks that much more richer. Compare this to our base tree with similar parameters. It looks different because there's no middle branch here and there are no middle branches here. So in this video, we'll see how we can start from, let's say, here to get to something like this. In fact, the end code is very, very simple. But obviously, it's important to understand why it works and how it works. We are here to enhance the Fractals and Recursion project from the YByte Python curriculum available at www.ybyte.in. We'll see how this whole thing comes together. Very interesting because this gets us deeper into how the turtle is actually moving. Now, one thing that is, I think, quite amply clear by now is that if I want to get three branches, then I'll have to call the recursion three times, just like I was doing for the square pattern. So that is a given. But it turns out that that's really all we need to do because my code is already set up for, let's say, everything else. So really all I'm doing is, in this case for three-level recursion, is to just add this one statement and that takes care of everything. But let's understand how this works. Remember, as always, let's look at the base case. So if I do, let's say, branch 80, 102, so level 2, I will move forward and I'll call turn right and I'll call branch 81. Again, I'll move forward and turn right by 20 because I'm assuming angle is 20 and I'm assuming the angle is same on the left and right here, just to keep it simple. So I say, okay, look, turn 20. So at point A, as we have seen before, we will be turning too much to the right. Before I can draw the next level, I must bring back my turtle. We do it in two steps. We first say turn right minus 40, which means too much to the left now. That's at point number B. Align it back at point number C, and then bring it back over here. In fact, nothing changes. This is what has been happening all the while, because now at point number E, basically we have a situation where my turtle goes aligned to the left side. So I take two times of, let's say, t times right minus 40, two times of the angle, because from being aligned this way, I now align this way, and I go and draw my second branch. Now remember, I must align myself back again to the parent here. So I do this. In fact, this is exactly the alignment what I wanted, because now all I need to do is to draw one line in the middle. So all I need to do really is to say, okay, look, please draw me a branch here, and I will be done because everything else is already set up. Now, obviously, an interesting variation here is, my left angle and right angle, and say even the center angle are not, let's say, equal. So center angle is 0 for me. Those variations can be built like we have discussed in the past for unequal angles. Similar logic will apply. Happy to discuss if you are interested. But basically what I'm getting at is that in order for me to go from two branches to three branches, okay, there's a mistake here, three branches, all I need to do is to just call this once again. I'm just showing it a base case, but we can see how this gets done. So I get here to my code. Now I have created a function called, basically branch 3, because I want to imply that there are three branches getting created here. I'm keeping the angle to just a single number, and I'm removing all probabilistic elements to it. They can, of course, be added in to, further, let's say, enhance this. But all I'm going to do is to call this branch 3 one more time. Notice the code right now is set up to give me this. Previously I ran branch 3 and I got this. When I run this piece of code now you notice the turtle is creating not two, but in fact three branches, and exactly what we had been looking for has been achieved. Let's try to look at this again. This time round, I am turning on the tracer functions because I want to see the output immediately. However, I'm going to do more levels of recursion. Now, important to realize that now the computational complexity of this has gone much higher, because previously for every level we got two branches, now we're getting three branches, which means it's becoming 3 to the power of something. So be careful, be aware of this, let's say, when you run this, right? But when I do this, you notice it takes a while, but I do get my tree coming out. Looks rather dense, but you notice that's because there are three branches going from each of those, and looks pretty cool. Now obviously we can apply a lot of other enhancements to this tree now. For example, we can change the angles, the left and right angles to be different. For example, we can make it probabilistic. For example, we can animate, and so on. So all those ideas can again be applied, but you get the picture that this is how we can make this, let's say, more richer. As always, building activities is fun and it's a good way to learn programming. Look at our website www.ybyte.in because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.